Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Sciences, SOS, Master's Degree Programs, M.Sc. Mathematics with Applications in Computer Science, MACS, First Semester, MMT-1 Programming and Data Structures, Block-1 Introduction to the C Programming Language, Unit-1 Getting Started. 1.1 Introduction. In this unit we will introduce you to the C programming language. We begin this unit with an overview of the C programming language, its history and the reasons for its continued popularity in Sec. 1.2. In Sec. 1.3, we start our discussion of the C programming language with a simple example program. We use the program to tell you how a C program is organized in general. In Sec. 1.4, we discuss escape sequences which output tab, new line etc. In the last section, we discuss some example C programs to give a feel for the language. Objectives. After studying this unit, you should be able to explain the advantages and disadvantages of C language, explain the general structure of C programs, and explain the purpose of escape sequences. 1.2 An overview. C is a general-purpose computer programming language. It was originally created by Dennis M. Ritchie, circa 1971, for the specific purpose of rewriting much of the Unix operating system. This now famous operating system was at that time in its infancy. It was first written for a discarded DEC PDP-7 computer by Ken Thompson, an electrical engineer and a colleague of Ritchie's at Bell Labs. Thompson had written the first Unix in a language he chose to call B. B itself was based on BPCL, a language that was developed by Martin Richards, another programmer. The intention of these programmers was to port Unix onto other, architecturally dissimilar machines. Clearly, using any assembly language was out of the question. What they needed was a language that would permit assembly-like, i.e., low or hardware-level operations, such as bit manipulation. At the same time, it should be usable on different computers. None of the languages then available served the purpose. They had to create a new one, and C was born. The rest is history. Unix became spectacularly successful, in large measure because of its portability. C, in which of most Unix was written, has occupied a preeminent position in the development of system programs. The success enjoyed by Unix, and the consequent popularity of C for systems programming, forced it on the attention of applications programmers, who came to appreciate the rich variety of its operators and its control structures. These enable, and in fact encourage, the practice of modular programming. The individual subtasks that make up a large program can be written in independent blocks or modules, each of manageable size. In other words, the language possesses features that make possible a divide and conquer approach to large programming tasks. When programs are organized as modules, they are necessarily well planned, because each module contains only the instructions for a well-defined activity. Such programs are therefore more easily comprehensible by other readers than unstructured programs. Another desirable quality of modular programs is that they may be modified without much difficulty. If changes are required, only a few modules may be affected, leaving the remainder of the program intact. And last but not least, such programs are easier to debug, because errors can be localized to modules, and removed. For a concrete example, suppose that you have to write a program to determine all prime numbers up to 10 million which are of the form k2 plus 1, where k is an integer, 2, 5, 17 and 37 are some examples of such primes. Then you can write one module to generate the number k2 plus 1 for the next admissible value of k, another module to test whether the last number generated is a prime. Organized in this way, not only will the program be elegant, it would also be easy to debug, understand or modify. Yet, C is not rigidly structured. The language allows the programmer to forsake the discipline of structured programming, should he or she want to do so. Another point of difference between C and other languages is in the wealth of its operators. Operators determine the kinds of operation that are possible on data values. The operators of C impart a degree of flexibility and power over machine resources, which is unequaled by few other contemporary language, except assembly language. But assembly language has disadvantages. It is not structured. It is not easy to learn. Moreover, assembly programs for any substantive application tend to be too long, and they are not portable. An assembly language program written for one computer cannot be executed on another with a different architecture and instruction set. 1.8 Summary. Cognitive psychology is the study of how people perceive, learn, remember, and think about information. A cognitive psychologist might study how people perceive various shapes, why they remember some facts but forget others, or how they learn language. Cognitive psychology is interested in what is generally called mental phenomena. In this sense, cognitive psychology is the scientific study of the mind. Then we took up the various research methods that we use in cognitive psychology. Every research has a goal and it is achieved through appropriate methodology. It was noted that the goals of research in cognitive psychology was to find the how and why of thinking. It was pointed out that there are distinctive research methods in cognitive psychology. Each method has distinctive advantages and disadvantages. It was also noted that cognitive psychologists often broaden and deepen their understanding of cognition through research in cognitive science. Cognitive science is a cross-disciplinary field that uses ideas and methods from cognitive psychology, psychobiology, artificial intelligence, philosophy, linguistics, and anthropology. Modern cognitive psychology freely draws theories and techniques from 12 principal areas of research, namely cognitive neurosis INTs, human and artificial intelligence, perception, thinking and concept formation, pattern recognition, developmental psychology, attention, language, representation of knowledge, imagery, memory and consciousness. Then we dealt with a brief history of cognitive psychology and highlighted the early thoughts on thinking, Renaissance and beyond and the status of cognitive psychology as of today. We then discussed some of the key issues in cognitive psychology highlighting nature vs. nurture, rationalism vs. empiricism, structure vs. processes etc. Thank you, subscribe to our channel for more updates, and we will see you with the next chapter. The success enjoyed by Unix, and the consequent popularity of C for systems programming, forced it on the attention of applications programmers, who came to appreciate the rich variety of its operators and its control structures. These enable, and in fact encourage, the practice of modular programming. The individual subtasks that make up a large program can be written in independent blocks or modules, each of manageable size. In other words, the language possesses features that make possible a divide and conquer approach to large programming tasks. When programs are organized as modules, they are necessarily well planned, because each module contains only the instructions for a well-defined activity. Such programs are therefore more easily comprehensible by other readers than unstructured programs. Another desirable quality of modular programs is that they may be modified without much difficulty. If changes are required, only a few modules may be affected, leaving the remainder of the program intact. And last but not least, such programs are easier to debug, because errors can be localized to modules and removed. For a concrete example, suppose that you have to write a program to determine all prime numbers up to 10 million which are of the form k2 plus 1, where k is an integer, 2, 5, 17 and 37 are some examples of such primes. Then you can write one module to generate the number k2 plus 1 for the next admissible value of k, another module to test whether the last number generated is a prime. Organized in this way, not only will the program be elegant, it would also be easy to debug, understand or modify. Yet, C is not rigidly structured. The language allows the programmer to forsake the discipline of structured programming, should he or she want to do so. Another point of difference between C and other languages is in the wealth of its operators. Operators determine the kinds of operation that are possible on data values. The operators of C impart a degree of flexibility and power over machine resources, which is unequaled by few other contemporary language, except assembly language. But assembly language has disadvantages. It is not structured. It is not easy to learn. Moreover, assembly programs for any substantive application tend to be too long, and they are not portable. An assembly language program written for one computer cannot be executed on another with a different architecture and instruction set. On the other hand, a C program created on one computer can be compiled and run on any other machine that has a C compiler. Possibly the greatest merit of C lies in its intangible quality, which can only be termed elegance. This derives from the versatility of its control structures and power of its operators. In practical terms, this often means that C programs can be very short, and it must be admitted, sometimes even cryptic. Indeed, there is a canard that C stands for cryptic. While brevity is undeniably a virtue, especially when you consider the vastness of COBOL programs, there can be too much of it. All too frequently in C programs, one comes across craftily constructed statements that take as much time to comprehend as they must have taken to create. In the interest of other readers, therefore, as well as you may find, in your own, you should resist that temptation to be cryptic that C by its nature seems to encourage. One common classification of computer language divides them into two broad categories: high-level languages, HLLs, and low-level languages, LLLs. An HLL is a language that is easy for a human beings to learn to program in. A good example is BASIC, with its easily understood statements. 10 let x equals 45. 20 let y equals 56. 30 let z equals x equals plus y. 40 print x, y, z. 50 end. An UL is a language that is closely related to machine or assembly language. It allows a programmer the ability to exploit all of the associated computer's resources. This power, however, does not come without a price. LLLs are generally difficult to learn, and are usually so closely tied to the architecture of the host machine that even a person who is familiar with one UL will have to invest a great deal of effort in learning other. Consider the following statement from the macro assembly language of MACS series of computers manufactured by the Digital Equipment Corporation, USA. POPR #M less than R6, R8, R3 greater than. It is highly unlikely that one who is not familiar with MACS's macro assembler will be able to fathom any meaning from this instruction. Moreover, UL programs are not portable. They cannot be moved across machines with different architectures. C is a considerable improvement on LLLs. It's easy to learn. It's widely available, from micros to mainframes. It provides almost all the features that assembly does, even bit-level manipulation, while being fairly independent of the underlying hardware. It also has the additional merit that its programs can be concise, elegant and easy to debug. Finally, because there is a single authority for its definition, there is a greater degree of standardization and uniformity in C compilers than for other HLLs. It has been often said with some justification that C is the Fortran of systems software. Just as Fortran compilers liberated programmers from creating programs for specific machines, the development of C has freed them to write system software without having to worry about the architecture of the machine that the software is intended for, where architecture-dependent code, i.e., assembly code, is necessary. It can usually be invoked from within the C environment. C is a middle-level language, not as low-level as assembly, and not as high-level as BASIC. In short, C has all the advantages of assembly language, with none of its disadvantages. And it has all the significant features of modern HLLs. It's an easy language to program in, and makes programming great fun. As we mentioned in the course introduction, we will discuss ANSI C, also known as C89. We will also mention some extra features provided by C99. We close this section here. In the next section, we will examine some simple C programs to understand the structure of a C program. 1.3 AC program. The best way to learn C or any programming language is to begin writing programs in it. So here's our first C program. See the practical guide for instructions on how to compile and link programs. Look at the screen. Listing 1, first C program. There are a few important points to note about this program, points which you will find common to all C programs. Programs in C consist of functions, one of which must be main. When a C program is executed, main is where the action starts. Then other functions may be invoked. A function is a subprogram that contains instructions or statements to perform a specific computation on its variables. When its instructions have been executed, the function returns control to the calling program, to which it may optionally be made to return the results of its computations. Because main is a function, too, from which control returns back to the operating system at program termination, in ANSI C it is customary, although not required, to include a statement in main, which explicitly returns control to the operating environment. Also, main returns an integer value to the operating system. So, we have added the keyword int before main statement. C99. The int keyword before main is not needed in ANSI C because a function without an explicit return type is assumed to return an integer value. This is not so in C99. If no return type is given, C99 compilers may compile with a warning, as it happens with GCC, but it is not compulsory to do so. The program may also fail to compile. We'll learn more about functions as we go along, but for now you may recognize them by the presence of parentheses after their names. Apart from main, another function in the program above is the printf. Printf is an example of a library function. It's provided by the developers of the C library, ready for you to use. C library provides a variety of functions. For example, C library provides many common mathematical functions like the trigonometric functions, exponential function etc. Apart from this, you may use other libraries that provide, for example, graphics functions. These libraries contain the instructions for the function in a compiled form or in the form of object code. So, you do not have to write code in your program for these functions. To enable the use of such libraries, the compilation of C programs is a two-part process. In the first part, the program compiles your C file into an object file. The C compiler remembers the functions you have called and the linker combines the translated version of the code you wrote with the object code already found in the library. The second step of the process is called linking. In addition to its variables, a function, including main, may optionally have arguments, which are listed in the parentheses following the function name. The arguments of functions are somewhat different from the arguments that people have. They are values of the parameters in terms of which the function is defined, and are passed to it by the calling program. The instructions which comprise a function are listed in terms of its parameters and its variables. In the example above, main has no arguments. Printf has one, it's the bunch of characters, more properly, string, enclosed in double quotes. This is easy, and when the printf is executed, its built-in instructions process this argument. The result is that the string is displayed on the output device, which we will usually assume is a terminal. The output of the program will be. This is easy, with the cursor stationed at the beginning of the next line on the screen. In C, a string is not a piece of thread, it's any sequence of characters enclosed in double quotes. A string may not include a hard carriage return, less than CR greater than, i.e. all its characters must be keyed in on a single line on the terminal. This is most certainly not a C string. Less than CR greater than It contains a carriage return character. As we have seen in the case of printf, when a function is invoked, it is passed the values of its arguments. It then executes its instructions using these values. On completion, the function returns control to the module from which it was invoked. The nice thing about a function is that it may be called as often as required in program, to perform the same computational steps on the different sets of values that are passed to it. Thus there can be several invocations to printf, within a program, with different string arguments each time. Also, a function can call other functions. For example, in listing 1 on page 9, the function main calls the function printf, with the text, "This is easy," as the argument. In a program for listing primes of the form k2 plus 1, we can have a function that computes k2 plus 1 for the next value of k passed to it. Another function can test whether the value of k2 plus 1 calculated by the first function is a prime or not. These functions could be invoked repeatedly, for different values of k. Functions will be formally introduced in the next block. You usually put a carriage return by pressing the Enter key. With some compilers you may not require the preprocessor directive #include less than studio h greater than, which we have written just before main, in listing 1 on page 9. These directives, unlike other C statements, are not terminated by a semicolon. Preprocessing is a phase of compilation that is performed prior to the analysis of the program text. We will have more to say about preprocessor directives later. Studio H is a header file that comes with your C compiler and runtime system and contains data that printf needs in order to output its argument. The #include directive causes the inclusion of external text, in this case the file studio H, in your sources program before the actual compilation proceeds. We'll have more to say about header files later. If you have problems, consult a resident expert. Let's go back to listing 1 on page 9. Observe that the body of the program is enclosed in braces. A pair of braces defines a block. A program may consist of several blocks, which may include yet other blocks, and so on. The left and right braces which mark a block may be placed anywhere on a line. You will find it easier to read and debug the programs if you align the same column. For the same reason, the braces of blocks which are nested inside other blocks are indented a few spaces to the right from the braces of the enclosing block. Listing 2, block structure. Look at the screen. In listing 2, note that each left brace is balanced by a corresponding right brace. Blocks contain statements such as printf, this is the innermost block, and C statements invariably end with a semicolon. C statements may be of any length and may begin in any column. Each statement may extend over several lines, as long as any included strings are not broken. In C, a semicolon by itself constitutes a valid statement. The null statement. Null statements are often very handy, and we will quite frequently have occasion to use them. While writing a C program, you can add comments, which are ignored by the compiler. Comments in programs are included between a \* pair, ****. This is a comment about comments. Comments may extend over many lines, but as a rule they should be short, ***. Comments are important because they help document a program, and should be written so that its logic becomes transparent. They may be placed wherever the syntax allows. White space, characters, blanks, tabs, or new lines. E1. Do you think comments can be nested, i.e., can you have a comment within a comment? Write a program with a nested comment and see if you can compile it. In discussion above, we mentioned that a C string cannot contain a carriage return. What should we do if want to break a long string? We have to use an escape sequence. Escape sequences are the topic of our discussion in the next section. 1.4 Escape sequences. You might be wondering about the N pronounced \n, in the string argument of the function printf. This is easy. N. The n is an example of an escape sequence. It's used to print the new line character. If you have executed programs 1 or 2, you will have noticed that the n doesn't appear in the output. Each n in the string argument of a printf cause the cursor to be placed at the beginning of the next line of output. Think of an escape sequence as a substitute character for printing hard-to-get characters. In an earlier section we learned that less than cr greater than s are not allowed in strings, but including n's within one makes it easy to output it in several lines. If you wish to print a string in 2 or more lines, place the n wherever you want to insert a new line in the output, as in the example below. Look at the screen. Listing 3 line breaks in a C program. Each n will force the cursor to be positioned at the beginning of the next line on the screen, from where further printing will begin. Here is part of the output from executing the above program. This string will etc. If a string does not contain a n at its end, the next string to be printed will begin in the same line as the last, at the current position of the cursor, i.e. alongside the first string. Though less than cr greater than s cannot be included in a string, if you must deal with a long string of characters that cannot fit conveniently in a single line, there is a way of continuing it into the next line. You can insert a \, followed by a less than cr greater than where you wish to break the string. This is a rather long string of characters. It extends over 2 lines. We have seen that the double quotes character is used to mark the beginning and end of a C string. How can the double quotes character itself be included within a string? This time the escape sequence comes to our aid. It prints as in the output. Similarly, the escape sequence helps print and the single quote character. All escape sequences in C begin with a \. Be careful to remember that is not the escape sequence for the double quote character, as it is in some versions of BASIC. In C, is the null string. The null string is not empty, as one might have thought. It contains a single character, the null character, ASCII 0, in which all bits are set to 0. We will see later that the last character of every C string is the invisible, null character. Its presence helps the computer determine the actual end of the string. Other escape sequences available in C are a ring terminal bell, the A is for alert, and C, extension. Question mark, ANSI extension. B backspace. R carriage return. F form feed. T horizontal tab. V vertical tab. 0 ASCII null character. Placing any of these within a string causes either the indicated action, or the related character to be output. In the next section, we will see some more C programs that will give you a better idea about the structure of C program. 1.5 Getting a feel for C. In this section we present a few programs that involve concepts which have not so far been discussed. They'll be covered at a leisurely pace by and by. As you read these programs, you may discover that many of their statements are self-evident. Those that may not be are commented. Create these programs on your computer, compile and execute them, and by the time you come to read about the features used in the programs, you shall have a fair idea about them already. The major change between ANSI C and the language described in the first edition of K and R is in the declaration and definition of functions. Program 1.11 below is an ANSI C compliant program, but it may not run on your machine if you have a non-ANSI compiler. Program 1.12 is the same program modified to run on classic C. So far, all the programs that we have written do the same thing every time we run the program. They print some text, the same text every time. But we would like to write programs that do different things at different times. For example, suppose we want a Program that adds two numbers and gives us the answer. How do we do it? For such programs we need programs that use variables. As the name suggests, variables store values that can change during the run of the program. The next program uses two values, 5 and 7, and stores them in two variables called x and y. If you want the program to do all the various operations for different integers, say 11 and 12, you can edit the source file, change the values of x and y, compile and run the program again. Go ahead. Try out 2-3 different values for x and y. Notice the int keyword before the variables x and y. This indicates that x and y will be used to store integer values. Look at the screen. Now, that wasn't very interesting, isn't it? Will it not be better if the program asks us for values of x and y when it is run? We have given below such a program. Look at the screen. Program 10. Program 11. Notice the line. #include less than math, h greater than. In the program, it loads the definitions of maths library functions. We need this line because we are using the sqrt function which gives the square root and fabs. That gives the absolute value of a number. This program uses the data type called float to store the absolute value of the coefficients and the discriminant because they may be numbers with a decimal point in them. We will discuss float date type in the next unit. Here is a C program that performs numerical integration using Simpson's rule. The program computes dx 1 plus x 2 by Simpson's rule using 4 subintervals. Recall Simpson's rule. Let h equals a minus b divided by n, where a is the lower limit of integration and b is the upper limit of integration and n is the number of subintervals, which should be even. If we write y equals f, a plus ih, then look at the screen. Note the definition of the function 1 divided 1 plus x square here. Since return can contain expressions, we have done the job of finding the value of 1 plus x square within the return statement. Return statement will simply return the value of the expression. We will see more about expressions in Unit 3. Look at the screen. 1.6 Summary. In this unit, we have studied the following points. 1. Because it was written for the purpose of porting Unix system and it was required that C permits low-level operations. It also enjoys the advantages of high-level languages, being comprehensible. It allows modular programming. 2. The C program is organized into functions and every C program must have a function called main. 3. To print certain special characters we need to use escape sequences. N new line. Single quote. Double quote. Backslash. A ring terminal bell, the A is for alert, and C, extension. Backslash question mark, and C extension. B backspace. R carriage return. F form feed. T horizontal tab. V vertical tab. 0 ASCII null character. 4. We also examined some example C programs. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.